Welcome to everybody. It's Ramchandra from CIVIL-MECH-MATHS Concepts channel, and this is the 7th lecture on SSC JE Fluid Mechanics. And in this, I have discussed MCQs and PYQs, and they are very useful. And how to solve the questions in the examination also in detail I have explained. And almost 7 videos I have released on fluid mechanics for SSC JE and RRB JE and RBI JE examination. Please view, review, and comment, and ask for any doubts. I will clarify, and please subscribe to my channel. If you like these videos, please subscribe to my channel to get the latest updates. It's again Ramchandra from CIVIL-MECH-MATHS Concepts channel. Best of luck to everybody. I welcome to my channel. Please listen to my lecture. Thank you. Welcome everybody. It's Ramchandra from CIVIL-MECH-MATHS Concepts channel. This channel is made with an intention to help the young aspirants to excel in engineering and mathematical concepts for various examinations ranging from SSC, RRB to UPSC examination including GATE. And in this, for SSC JE, for mechanical and civil engineering, I started giving lectures on fluid mechanics, and I have already given 6 lectures on fluid mechanics, and today I will be discussing on certain topics, certain MCQs and previous year questions given in SSC JE examination. Especially in SSC JE 2024, I have collected some good questions and which I wanted to explain in detail so that you can understand the length and depth of the questions, and also you can understand the concepts behind to answer the questions with easiness. And these questions will depend upon, they are based on the topics which I have covered till now. And in the last lecture, I have covered about center of pressure, center of gravity, and pressure distribution and pressure diagrams for a horizontal plane surface, and for a vertical plane surface, for an inclined plane surface, and for a curved surface. In detail, I have given lecture how to find out the center of pressure, center of gravity, and then the position of the center of pressure and center of gravity for a vertical plane and also for a horizontal plane surface. And I have also explained about the resultant pressure force on a curved surface and also the direction of the resultant. Now, let us start answering the questions one by one. First, the center of pressure is independent of what? To answer this question, we should know what is the center of pressure, which I have explained in the last lecture. For example, you take out the free surface of the fluid as shown here, free surface of the fluid, and let us say there is a vertical plane surface under the submerged in the fluid under the free surface, and the center of gravity of that plane surface, which I have explained in the last class. The center of gravity is Cg, and the distribution of pressure, which I have already explained to you. The distribution of pressure as per pressure diagram, the distribution of pressure will be like this. and let it be atmospheric pressure, and from this A, the top of this and bottom of this vertical surface B, the pressure distribution will be like this. Pressure will be increasing. As the pressure increasing, as you move downwards, the center of pressure moves depending upon the shape of the plane surface and depending upon the position of the plane surface below the free surface. And this, if you take it as dH, and if you take this as a H, and center of gravity height is h bar, and there will be center of pressure will be below the center of gravity, because center of gravity is fixed. It only depends upon the height between free surface top and the vertical surface top. It doesn't vary with the height of the fluid, because center of gravity is not changing, whereas center of pressure will always be changing with depth. It increases with depth. The center of pressure changes or increases with depth. Now, this is called as center of pressure. H star is center of pressure height below free surface. H bar is center of gravity, whereas center of pressure is equal to IG by AH bar plus H bar. This is the formula which we have derived in the last class. For definition, you please see my last lecture. You will understand where Ig is the moment of inertia with respect to center of gravity. It is fixed for the given geometry of the body. H star is equal to center of pressure, Cp, center of pressure height below the free surface, is equal to H star is equal to Ig by AH bar plus H bar. H bar is for center of gravity, H star is the height below the depth below the free surface for center of pressure. Now, the center of pressure is independent. It is independent of density. That means center of pressure depends upon moment of inertia Ig, area A, and action of center of gravity. These three, and is independent of density of fluid, because there is no term density of fluid in this particular formula. Hence, answer is density of fluid. Now, next question. Center of gravity of a sphere from geometrical center is at a distance of. A sphere is there. Sphere is nothing but three-dimensional circle. For a three-dimensional circle, that is sphere, this is the center of gravity, and also this is geometrical center. Both are same. Both are same. Because of the symmetry of the shape, we will get both as same, because in a sphere you go from any direction, you move in any direction, radius is same. You move in any direction, radius is same. Radius is not changing. The center of gravity is same and geometrical center is also same. What is the geometrical center? Geometrical center is nothing but the center of the sphere. What is the center of gravity? Center of gravity is nothing but where weight is concentrated. Weight is concentrated, for example, weight is concentrated at the center of the sphere for a sphere. If, for example, the shape is like this, let us say, weight is more in, let us say here it is like this, weight is more in this portion, more weight because of the shape, here less weight, let us say. Then what happens? Center of gravity will move towards here, center of gravity will be here. For example, something is like this. This is the center, geometrical center, let us say this is the geometrical center. Center of gravity will be here. Because more weight is towards left side. Whereas in a sphere, this is the geometrical center. Center of the sphere. And the sphere has uniform shape. The weight is also concentrated here only. That means both are same. When both are same, the distance between them is 0. Answer is 0. I think with this you might have understood what is center of gravity and what is geometrical center. Now, let us move on to next question. These questions are given in 2024 SSC JE examination. You just see, these are all conceptual questions. Once you know about the concept behind the question, you can easily answer them and accurately you can answer them. They are easy questions, but conceptual questions. And these are the questions given, taken from website and different sources. Question paper is taken and I have answered them. Now, the accuracy of this question paper you can check with the public domain websites of SSC. Now, the value of gauge pressure is, I have already told you, there is a free surface, this is the free surface of the fluid. As you go below, this is atmospheric pressure. Free surface will have atmospheric pressure exposed to atmosphere. I have already explained in detail in my last 6 lectures about this concept. The pressure diagram will be like this. No, it will be like this. This is A, P atmosphere, PA, and this is PB, P atmosphere plus rho GH. PB is equal to PA plus rho GH. This is what is we have many times repeated in the previous classes. As depth increases, the pressure intensity increases, the pressure increases. PB is equal to PA plus rho GH and PA is equal to free surface pressure is equal to P atmosphere. That implies PEB is equal to P atmosphere plus rho GH. At any point, the pressure is equal to P absolute is equal to, we know, P atmosphere plus P gauge. That implies when we compare these two formulae, Pb is equal to P atmosphere plus rho gh, P absolute is equal to P atmosphere plus P gauge, then what will be the value of P gauge? That implies P gauge is equal to gauge pressure is equal to rho gh. This I have explained in detail. If you want further information on this and to clear the concepts, you can refer to my earlier lectures. This, any pressure measured above the next question. Rho gh is the answer for third question. And next question. The pressure measured above the atmospheric pressure is called what? Here atmospheric pressure is there. Any pressure above is gauge pressure. Any pressure below is vacuum pressure. P absolute is equal to, please remember this formula, I have explained you many times, P atmosphere plus P gauge. This can also be written as P absolute is equal to P atmosphere minus P vacuum. If you measure the vacuum pressure, the absolute pressure will be P atmosphere minus P vacuum. Whereas the absolute pressure, here pressure measured above the atmospheric pressure. This P vacuum is below the atmospheric pressure, below, because negative sign is there. P gauge is above because positive sign is there. Here it is negative sign. That means pressure measured above the atmospheric pressure is P gauge. That is, P gauge is nothing but gauge pressure. Below the atmosphere, this is atmospheric pressure. Now, understand what is vacuum pressure and what is gauge pressure. Any pressure above atmospheric pressure, measured above atmospheric pressure, is gauge pressure. Below atmospheric pressure means what is there? For example, a pipe is there, a tube is there. In the tube you have removed the air. What happens? It shrinks. That means the pressure inside the tube is lesser than the atmospheric pressure. Hence, tube shrinks. And there will be a vacuum developed inside the tube. Whenever there is a bursting is there, tube expands initially, pressure goes out, and once tube pressure inside the tube, once the pressure comes below atmosphere, it shrinks. That phenomena you might have seen even in balls also. For example, one ball you have just blown it and that ball is in the circular shape. If you take out the pressure from that ball, if it goes below atmospheric pressure, the ball shrinks. That is the vacuum pressure. That means any pressure happening below the atmospheric pressure, then that causes the vacuum, that is called as the vacuum pressure. And a ball expands, that means if you are blowing the air inside and the pressure inside the ball is more than the atmospheric pressure, it expands. That is called as the absolute, that is called as the gauge pressure. That means a pressure measured above the atmospheric pressure is gauge pressure, a pressure measured below the atmospheric pressure is vacuum pressure. Now, let's go to next question. In a laminar flow through pipes, shear stress distribution is. I have explained in my first and second lectures itself that fluid mechanics, laminar flow through pipes. Let us say there is a pipe and this is the diameter of the pipe. I have already told and explained in detail. What is the shear stress? Shear stress let us talk about the velocity distribution first. The velocity distribution is like this. Shear means stopping, shearing between two surfaces. The velocity is like this, velocity of the fluid. This is velocity distribution. Or we can say velocity profile. Velocity profile for a laminar flow. This is the shear stress distribution. There will be no shear in the center, almost zero shear. There will be maximum shear due to viscosity. Shear happens due to viscosity. This is the shear stress distribution. What is the shear stress distribution? This is the pipeline. This is the center. This is the pipeline wall. This is linear. Shear stress distribution is linear. If in your examination, if question is asked about the velocity distribution is equal to parabola, whereas shear distribution is linear. Answer is linear. Regarding this, I explained in my previous classes very well. You can see them. Any questions? You can ask me. Next question. The position of the center of pressure. You just see. In 2024, on center of pressure itself, 2 or 3 questions are there. Just only twisting, that's all. In the same question paper. If you refer to my previous lecture, center of pressure is explained in detail. Very well it's explained. Now, let us draw the free surface. Free surface. And let us draw the vertical surface. Vertical plane surface. I told you just now, center of gravity is fixed for the shape. It will not vary except for the difference between free surface and top surface of the vertical pressure. Center of gravity is here because it doesn't vary with depth except for the difference between free surface and top of the vertical surface, that is H bar. Because of the pressure profile which I have explained here, PA and PB in this diagram, center of pressure is equal to H star. What is the formula for center of pressure? Tell me. H star is equal to Ig by AH bar plus h bar. For any shape, vertical surface, there will be moment of inertia. Ig is a positive number. Area cannot be negative. Area is a positive number. And h bar cannot be negative. It will be a positive number. That means this whole is positive. This whole is positive. H star is equal to some positive number plus h bar. Please understand the logic. Which implies h star is greater than h bar. Please remember this. From the formula itself, from the diagram also, h star is greater than h bar, which implies the position of center of pressure is below the center of gravity. Answer. Which implies center of pressure is below center of gravity, because h is measured from the top of the free surface. Center of pressure is below center of gravity. Regarding this, I have explained in detail in my previous lecture. I think this is sufficient for you to answer this. You just see there are no complicated mathematics to be done here. You have to understand from the formula also we have proved it, from the geometry also we have proved it that the position of center of pressure is below the center of gravity. Position of below center of gravity. Now, these are all the real questions asked in the 2024 SSC JE examination. From the topics which I have covered in the last 6 lectures only, almost 10 to 12 questions. Please try to understand the weightage and the importance and the ease with which you can score. In a laminar flow through pipes, this stress distribution is linear. I have already discussed with you. It is being asked repeatedly because the importance of the question. As an engineer, you should know this is the velocity profile, this is the stress distribution profile. This is linear, this is parabola. This is velocity, this is shear stress. Please remember this. This is velocity. Some questions, center of pressure, stress distribution, velocity distribution, these are important topics in fluid mechanics. They are being repeated. Now, it's an important, some good question. Pumping from earth surface to overhead tank. Now, let us say there is a pump here. And there is an overhead tank here. Pump is run overhead tank and the height is h. This is the earth surface. earth surface. On the earth surface, pump is kept, and we started the pump, and pump started pushing the fluid or water to the overhead tank. Now you tell me, this pushing of water, usually water flows from fluid flows from higher elevation to lower elevation. In thermodynamics, it flows from higher temperature to lower temperature. Heat flows from, or fluid flows from higher elevation to lower elevation and higher temperature to lower temperature. Higher pressure to lower pressure. These are the practical examples which we see in our existing world, like Jog Falls if you take, some Himalayan falls if you take, water flows from top to bottom. Water flowing from top to bottom is natural. Water flowing in this direction is natural. Anything, if water has to flow from bottom to top, this is forced. When you apply force only from bottom to top, the water flows. For example, you have got a stone in your hands. You can drop it easily without any force. It will drop to the surface, earth surface easily if you leave it. But if you throw it, you require some energy. But to leaving it, you don't require any energy. Without energy, you can leave, it falls automatically. When something is falling, that is gravitational pull. If something is forced, that is forced against the gravitation, against gravitational pull. And force is nothing but pressure. Pressure and force are interrelated because pressure is equal to force by area, normal force by area. That means anything moving from bottom to top, it requires force. That means it requires pressure for the flow. Then this type of flow is called as pressure flow. When there is no force applied, automatically it falls down. That is a gravitational pressure. That is gravitational flow. There is no pressure. Gravitational flow. Gravitational flow from bottom to top is gravitational flow. From top to bottom is pressure flow. Please understand the difference between gravitational flow and pressure flow. Pumping from earth surface to overhead tank requires pressure, requires energy, requires force. Hence it is called as pressure flow. That means with the little definition of pressure, how many questions we are getting? By applying your conscious mind and presence of mind in the examination, you can easily score well in the examination when you link your subject knowledge to the practical knowledge. Now you see, Atmospheric pressure, gauge pressure, everything it's coming again and again. The questions are being repeated. When atmospheric pressure is taken as datum, the measured pressure is gauge pressure. Direct answer. Many times I have told you. This is P atmosphere. And here it is PB, that is P atmosphere plus rho GH. If P atmosphere is equal to 0, rho GH is equal to gauge pressure. This is the measured pressure. Please refer to my previous lectures for further understanding. Now you just see. 10th question is very conceptual question, interesting question and very important question to understand. For an oil of mass density 800 kg per cubic meter, calculate the height of water required to develop hydrostatic pressure equal to height of oil as 30 meters. Take G as 9.81. Answer is 24 meter. How we got it? I explained in my previous lectures numbers 1, 2, 3, that pressure is nothing but rho GH. Pressure can be expressed in Newton per meter square, kilonewton per meter square, meganewton per meter square, or Pascal, kilopascal, megapascal, or it can be measured in fluid column, like 1 atmospheric pressure is equal to 760 mmHg. I have derived also how we got this 760 mmHg. Now, we understand, we apply this concept P is equal to rho GH and find out the equivalent water column. Initially we have used the oil and we found the height as 30 meters. Pressure is not changing, pressure is rho GH, that is constant. Pressure is equal to rho GH, that is equal to rho 1, G is constant, H1 is equal to rho 2, G H2. That we can say H1 is pertaining to, let me say, oil. Rho 1 is oil, H1 is oil, and rho 2 is water, H2 is water. That means rho oil into G into H oil is equal to rho water into G into H water. In this, G and G are gone. Rho oil, H oil is equal to rho water into H water. Rho oil, H oil is equal to rho water into H water. Please remember this formula. Now, we have to find out the H water. We have to find out the height of water. Here you see, what is rho oil? 800, because rho is 800. And for water, H oil is, height of oil is 30, is equal to rho water. What is rho water is 1000, and H water is not known. Raw water we have taken as 1000 kg per cubic meter. Please remember this value. Density of water usually is taken as 1000 kg per cubic meter. This you have to remember, this constant you have to know. Then only you can solve this problem. Then H water is equal to 800 into 30 by 1000. That means this 0 is gone, this 0 is gone, these 2 zeros are gone, these 2 zeros are gone. 8 into 3 is equal to 24 meter. You just see, in 10 seconds we have solved. Provided we should know that the pressure does not change, rho GH is constant and G is constant, hence rho H is equal to constant. Rho 1 H1 is equal to rho 2 H2, that is rho oil into H oil is equal to rho water into H water, and the rho of water is equal to 1000 kg per cubic meter, which is not given, it should be assumed. It should be known to you. That means it's a twisting question, a very good question, and these are all questions. Honestly, you tell me, when you know the concepts, will you be able to answer all these? You will be able to answer very easily. Almost 10 questions in 2024 question paper on the topics which I have covered. Many topics are yet to be covered. Yes, in fluid mechanics itself. These 10 questions with the basics which you listen to my lectures, you will be able to solve them in seconds with accuracy. Hence, please listen to my lectures again and again. Make a notes. Do not hesitate to ask questions to me. I will answer them. If you have any doubts about center of gravity, center of pressure, you please ask me. That's very important. In the next class, we may be going for buoyancy and Archimedes principle. In that these things will be very, very useful. And we can't say that my syllabus is this much, I will get only from this syllabus. In competitive examinations, questions can be of any depth. They will be mainly conceptual questions, and you will be able to easily solve them once you know the concepts. Like you see, these questions how simply and how easily we have done. And listen to this lecture, listen to my previous lectures, make your self notes and repeatedly listen to them, make a notes, answer the MCQs, and then these are the questions which are asked in previous year questions I have taken out. Once I complete buoyancy and flotation, Archimedes principle, then before going into the kinematics of the fluid mechanics, once I complete buoyancy and flotation, I will make my own MCQs and give a set of 10 MCQs to you for your brainstorming. Best of luck to everybody. It's Ramchandra again from CIVIL-MECH-MATHS concepts, and do better. And for RRB JE, RBI JE, SSC JE, time is there and you can prepare well, focusing on the subject. One by one we will be moving. I will be moving slowly, so that because time is there, let us not hurry things and let's understand clearly the subject, and let's focus on the subject matter and concepts, and let's move towards completion of the subject. Best of luck to everybody in your examination. Thank you for listening to me. Please view, review and comment and ask me any questions. Please see my 6 videos previously which I have put on fluid mechanics. Listen to them, view them, review them and comment. And any questions if you have, please ask me. I will answer them. Best of luck again. It's Ramchandra from CIVIL-MECH-MATHS concepts. Thank you for listening to me.